Now we're going to go over our electrical boards, our little circuits. Now, this we're going through switch, relay, we've got LEDs and lamps. Okay, with the switch turned on, only the LED is illuminated. And the lamp B isn't illuminated, so is that lamp faulty? Okay, if we want to know if that lamp is faulty, then there are several checks we can make. But one thing we must do, well, let's follow the circuit. We're coming through the relay and it's coming through this wire, through the LED, and to attain a ground, it's got to go through this lamp and then over to a ground. Now, if this lamp were faulty, then this would be an open circuit, so that the ground pathing for the LED wouldn't be possible. So the LED wouldn't be illuminated. Another check we can make is going from this side of the lamp to confirm that to a ground, and we're going to be looking at our voltage. And with that, we have no voltage, but we go on this side. Where are we? Okay. And there. Okay, we've got voltage to there. And we have voltage to there. So we have voltage that's passing through all the way through the light bulb. But what is causing the light bulb not to illuminate? The current flow that's possible to be transferred through the LED is such at a low rate that it is not sufficient to illuminate this lamp. This lamp takes approximately 20 times more to illuminate than this LED does. So this is kind of acting like a resistor. It's choking it down. It can't give it enough power to illuminate this, but it still delivers a pathway just as it would. It's just a different wire source to go to a ground to where it completes the circuit. Now, if we you'd ask, are all the circuits fuse protected? In this particular instance, they are absolutely fuse protected, because you see your power supply, your primary input comes over, it goes through the fuse, and then over here to this lead, which is going to terminal 30 of the relay, which is the input. Now, remember, on our breakdown of the relay, terminal 30 was the input for the two other output terminals. And then it comes over here through the switch to activate the relay itself. And that's all this switch is doing. Okay, now the switch turned off, that deactivates the coil within the relay. So as you remember on our relay earlier, when the electromagnetic coil releases that, and you saw that that terminal sprung over to that other contact point. That's what occurred right now when we turned the switch off. Now, okay, then the question is asking it's between terminal 30 and 87A. That's incorrect. To activate the coil, it's 86 and 85. And when you deactivate the coil, it's between terminal 30 and 87A is where it makes connection. And that sends power to this board and this board, and then goes to ground. Okay, if you measure the voltage between these 2 points, between points 1 and 2, you observe that it's only 8.96 volts. That is due to resistance of the filament itself. Okay, now you see that this board, the lamp is much dimmer than this board. Okay, think about this again. You have resistance and you have lower voltage here. And this lower voltage supply, and then it's got to go through the resistance of the filament on this one, and you look at the voltage there, 4.89 volts. However, if you take and you add that 8.99 and this 4.89, you should come up with your supply voltage, which is 13.9. You take the sum between these two. And that is all on this first electrical board. We shall be with another board shortly.